Hello guys and welcome to the fifth episode in the I-beam Trolley series, which is season 1 of the mini projects, season in quotes. So today we'll be doing the spacer shaft. It's the shaft that the washers will be using as spacers go over, and as the I-beams become wider, you remove the spacers and the carriers, you put more washers on the inside, less on the outside, tighten the nuts back up, and now you have a trolley that can fit a wider I-beam. So that's what we'll be doing today. But as I just described, we need to account for the widest I-beam that this trolley is going to be used with. So let's jump in and I'll show you how to do that. Now, the first thing we want to do is bring our I-beam table back up. So here we are, and we said that our trolley is going to be used with these I-beams. So the widest one is a 4-inch. So I want my spacer shaft to have space for washers that, when stacked, they're at least 4 inches tall. But I want, a couple of spacers more on either side. So that's what's going to guide my final, length. So the washers I'll be using as spacers are washers for a 1-inch thread, right? Even though the 1-inch part of the cylinder is going to be unthreaded. And then on either side, I will be using a 3/4 thread. I will have a reduced diameter. I'll thread a 3/4 thread there, and I'll screw a flange nut on there. And the flange nuts on either side is what's going to be compressing the washers and keeping them in place. This is going to be abundantly clear in the final episode of this series, where we're going to be doing the assembly. You'll see how this works. But that means that I need to know how thick the washers are. So I'm going to go into McMaster Car, washers, inch, 1-inch, right? That's what a general purpose. That's what I'll be using as a spacer. And there you go. It's got an ID of 1.062 inches and an OD of 2 inches. Now the thickness, it says it varies from 0.118 to 0.132. That's why I want a couple of extra washers on either side. I don't want to be caught out by that, right? So I'll have a couple of extra washers, and then I'll design the washer to be at the maximum thickness, right? And I'm not even going to download this. It's just 2 circles and an extrusion. I'll be designing that inside the assembly when I get there. But this is the thickness I will go for. So let's start designing the shaft, and I'm going to call it spacer shaft. And I just want a 1-inch circle, and I need to change my units to inches and use dual dimensions. And then I'll extrude for, well, first of all, mid-plane. I did that with the tie tab move. You can check that out in my black belt video. And I want 4 inches plus 4 times the thickness of the washer, which is 0.132. And if I edit my extrusion again, that is the total length, 4.528. Okay, now to that, I will be adding a couple of threads, and I want these to be 3/4 threads. So I'll do 3/4, and I'll extrude that for, yes, I need to check that out, because I will extrude that for just over the height of a 3/4 inch flanged nut. So before I go into my extrusion, I need, well, let's get the sketches showing, but I need to go back in here and look for a flanged nut. That's for a 3/4 by 10 thread, right? So the height of that is 41/64. So I'll just go in here, right? I'll select this, extrude it for 41/64. How much is that? Okay, and if I do 11/16, is that more? Yes, that's by how much I will extrude that. And hit OK. And then I'm going to go here in the right underneath the hole tool, click that little triangle and get an external thread. And I will select the outermost edge, right? Now, I want to be doing ANSI unified course. It picked up that it's a 3/4 thread. It's telling me that the unified course thread for that is 3/4 by 10 class 2A. That's fine. And I love this little option here in a Libre. It says create chamfer on edge. There you go. And okay, and this goes on for a 1-inch depth. Of course, my thread will end there, and I might as well say so. Or I could even open up the equation editor, right, and link the two. So that's the value. That's the 11/16, right? It's the length of extrusion 2. So I might as well link that and hit OK, and that's it. And now all I need to do is mirror the thing. I don't think I can mirror. Yeah, so I'll move the external thread underneath the mirror, and then I'll just go in and select the other edge as well. And Libre knows what I'm on about, and it creates the shaft for me. And then I also want a small chamfer here, a small one. Yeah, that's fine. A small chamfer there just to help me to get the shaft through the hole every time. And that's it. That's the design of the shaft. And when we're doing the 2D mechanical drawings that will get sent to manufacturing for a shaft like this, that's where we'll be specifying all of our tolerances. Although this has a very, very loose tolerance, it should go through that hole very, very easily, right? And just to make sure that our design is correct, I will, first of all, I'll save that as the spacer shaft, and then I'm going to use it to create an assembly. And this is just going to be a test assembly to make sure that the nut I selected and the washers will work and everything is going to be in place as it should be. Okay, so when I'm clicking the origin, I'm just placing the first part so that the coordinate systems of the two match. I will then anchor it, right? And to get a new part going, this is going to be the 1-inch washer, and I'm just going to start a sketch on the surface. The ID was 1.62 inches, and the OD was 2 inches. Okay, so I will extrude that for not that way. I want to go the other way, but it's 0.132 in reverse. 0.132 inches in reverse. So this is going to be the washer that I will be using as a spacer, right? And they'll be packed all the way through the cylindrical piece of this shaft. And then on the end here, I will put on the 3/4 flanged nut, which is here. So that's how I use McMaster-Carr. I download the step file. I don't touch anything. I go into my assembly, insert design, bring it in from the download section, right? Because as it's bringing it in, it's going to turn it into an Libre part. And there you go, file imported without errors. Now I wanna, okay, so I wanna say, let's open up my assembly constraints. I wanna say that this and this is concentric. That's great. And I wanna select, okay, I'll just say that this surface, yeah, this surface goes all the way in. I mean, it's just to show you how this works. And there you go. This is how far out the thread is going to be sticking out. I can make that larger if I want to, but I can see that generally this will work, right? I will stuck my washers in there, and when I put the nut on the other side, they will create a solid stack. Nothing will be able to move, and that is what I want. And actually, to give me some more adaptability, I'll just make these a bit longer. Right. So let's test assembly. Yeah, I wanna in the downloads folder. I want to be in the IBM Trolley folder. So I'll hit OK. Okay, I'll just open this buck up, and I will hold Control, double click on the feature, and I get this back. I want to, you know what, I'll just make it 3/4, and that's it. I'll save it, and close this as well. And now, when I open my test assembly, you will see that the thread sticks out a bit more, and that's fine. That's all I needed. So this is the spacer shaft. This will look a lot more useful and interesting when we do the assembly in the last episode, because you'll see how this works. I find this a great idea. Whoever thought about it first was a really clever guy. Now, next episode is the hook, and then the final episode, which is the assembly. I hope I'll see you then.